button. All right, before today, I'm hoping should be fairly quick, fairly easy. It's mostly about ratio stuff. If y'all remember, our ratios was this over this. Maybe you do a little bit of solving proportions, Jesus fish. You know, Jesus fish makes a comeback. That was probably everyone's favorite lesson of last semester because it was so easy. But just remember, there is a good chunk of you that did not turn in any daily work with our quiz. There's a number of you who did not do the quiz for various reasons. Make sure you do the review beforehand. Okay, it's all, you don't have to have the handout, but if you want it, I got it over here. Grab one at the end of class if you have not already done your review and quiz. Get the review done before. All right, so when you come in tomorrow, you can just do the quiz and you're done. Because y'all know early release schedule for a Maroon Day, we haven't had too many of them this year. When there's an early release Maroon Day, that means if you are not locked down in Spartan time, meaning you have earned your way out of Spartan time, you are all C's or better, all of the upperclassmen, they get to leave, like at 11:24. They don't have to show up for Spartan time at all. I'm not sure how your freshman Spartan time advisors are running that. If you have to stay the entire time, or if it's at your Spartan time teacher's discretion. But I would check with them. Just nominate one person of the group to go ask, like, hey, do we get out or not? Usually freshmen don't, but maybe they will because it's an early release Maroon Day. So every now and then, freshmen get to get out with the rest of the pack. Okay? So because we have smaller amount of time for Spartan time tomorrow, if you did not already do the review and you need to make up that quiz, do the review tonight. It's YouTube video. It's right there. Okay, poke the button. It's on Planbook. Okay, go through the review beforehand so that when you come in at 12:09 on tomorrow, then you can just take your quiz and you're done. Maybe if you're one of the kids who actually does all your work, I pretend that you were here until 1 o'clock and just let you leave. Who knows? Okay? All depends on your relationship with the teacher determines what they're going to let you get away with. You all know that. But moving in, 5-2, we don't have a daily quiz because last time was quiz. So start with, at the beginning, can you answer their question? You got two little neon blue stick figures staring at each other. Lightning go boom in between them. Can you figure out a rule for this? Yeah. Freshman. Oh man. Y'all killing me. Regular or extra crispy? Okay. Okay. Freshman. All right. This idea of a ratio is I compare things, right? If there's, I don't know, if there's twice as many girls as guys out on the dance floor at the homecoming dance, okay? If it's a ratio like that, and I say, well, I don't know this number, but I know that there's 18 guys in there. Okay, I can use the ratio to figure out what comes next. In this case, it was 10 seconds to hear the boom 2 miles away. It was 15 seconds to hear it 3 miles away. What's my ratio? Okay, you just divide, right? And you make sure that it's the same both times. That's the catch. See, if 10 seconds and 2 miles, I would say 5 seconds per mile. Or you could swap that around. Remember our unit rates from last semester? If that's a ratio of 5 to 1, 15 to 3 better also be 5 to 1 for it to match. That's what's called direct variation. I can just now multiply anything by 5 and I'm done. Okay? Directly to answer. Varying directly with a thing means I don't have to have a big complicated equation. I don't even have to do that rate x plus start thing we were doing 2 weeks ago. I just multiply by number and I'm done. Okay? Directly to answer. Direct variation is nice like that. Okay? I know that most kids are never, ever, ever going to read a math textbook. But this is all clipped straight out of your math book. Okay? Math textbooks, they're tough to read. A direct variation is a relationship that can be represented by the function y equals k times x, where k is not equal to 0. The constant of variation, those are big words, lots of syllables. I've had kids actually yell at me and say, stop using big words around me, you make me feel dumb. Like, there's too many syllables in your speech, quit it. Okay, so we do want to know the vocabulary. Direct variation. Y equals something times x. K is the something. So if I said there's twice as many girls as guys in the gym at the dance, my constant of variation, the thing I'm multiplying by, is 2. It's that simple. But they have big words attached to them because we have to say it with appropriate vocabulary. Okay, so if you want the constant of variation for a direct variation k is the coefficient of x. Boy, those are big words. Maybe next to that you write in the margin that k is thing you multiply by. Just little things like that, telling yourself this is what it means. The constant of variation, k, in that equation, is just the thing you're multiplying by every time. Maybe, as we're getting into this whole function, input, output, domain, range thing, we could also write y equals k times x is also saying my output is my constant of variation times my input. Okay? The constant of variation. So when I have my input, there will always be twice as many girls as guys on the dance floor. Now, my input will be the number of guys. I know there is 38 dudes out there. Okay, times 2. Straight to answer. Directly to answer. It's not times 2 and then subtract 15. It's not square it, divide it by 2, minus 5. It's not a bunch of steps, it's just straight to answer, which is why we call it direct variation. Also, if I want to know what that constant is, if I want to know the thing I'm multiplying by, well, I work backwards. I divide. Take output divided by input, you'll know how much you multiplied by. So, first up is, can I even write it as direct variation? If I can't write it like this, with no other junk next to it, it's not direct. It's an equation. It might even be a function, but it's not direct. Get y by itself. This is why we spent so much time on equations and literal equations and formulas. Divide by 7 on both sides. Now remember, if I have 2x over 7, that's the same as 2/7 times x. Can write it both ways. So since this one is y equals something times x, it's direct variation. So I'd say yes, and I'd also identify that that constant of variation, the thing I'm going to multiply by every time, is 2/7. Not tough. Now, the next one, I want to get y by itself as well. I'll subtract 4x. There was a bunch of us first semester who liked having that little divider line there so we don't accidentally screw things up. Make sure you're doing the same thing on both sides. And zeros out, I have 3y is, these are not like terms. Don't try to put them together. Just leave it. Okay? You can't mate a turtle and a giraffe. Fun to watch, doesn't accomplish anything. X and 8 are completely different critters. So don't try to put them together and say that that's 4x positive. Okay? Last part is divide everything by 3. But when I get my y by itself, yeah, I have a function. It's even a line. But is it y equals thing times x and nothing else? No, you got other junk with that. That'd be like if I said, get to the point. And then you told me the same story you just told me to get to the point. I don't want that. I want to know if it's direct. So that one would not be direct, so I wouldn't even say a constant of variation because it doesn't have one. Okay? Can you rearrange this? Try it. Can you get y by itself and it looks like a direct variation? Thing times x. Use all your skills from last semester, moving equations around. How do you get y by itself? Add or subtract this thing, multiply or divide that thing.
Could I just put this whole thing on top of that and call it a day?
I would rather we did the 3 to each of them individually, because that's kind of what we're going to be doing for the next 2 weeks. Because we want those terms separated moving forward. You'll literally see why on Thursday. Okay, don't overthink it. If I want y by itself, who's got to get out of there? The 4x. It's a completely separate term, so move it to the other side. Zeroes out. I got 5y is nothing minus 4x is just negative 4x. Get y by its lonesome. Divide both sides by 5. Show that that's a 1. And just like we did last time, if it's negative 4x over 5, I can just kind of pull that 4 off of the top and call that negative 4/5 x as a coefficient of it, the thing out front. Which is perfect because that tells me, yes, that is direct variation, and k is whatever went in front of x. We start with direct variation because it has to deal with input-output ratios. You may have seen this in physical science, where you talk about, have you done gear ratios? Have you done that in physical science? Like if this one is spinning at so many revolutions per minute, then this one is going to be 3 times as much, this one is 2 times as much. If I crank this 5 times, how many times does this? No? Huh. Anyway, direct variations used a lot in science. You'll get there. You'll get there. You're just starting. What that direct variation allows me to do is just multiply by thing, get straight to answer, no farting around. So, the nice part about this whole direct variation thing is it creates proportions. If it creates proportions, then I can solve them. And I can find out if y varies directly with x. Suppose y varies directly with x. What they just said is y equals k times x. K is, divide by x, y over x. That's what this means. It says it fits the criteria of the stuff we just said. It's set up like this. And then they tell me y is this, x is this. Okay. So if y is this and x is that, y is 35 when x is 5. Reduce it down. What is k? 7. So if I want the output, I'm just going to take my input times 7. That is now my ratio. So what is y when x is 9? Now I know that if k is 7, I can take 7 times the thing. Now this is only one way to set it up. The other way, see how this is y over x, ratio. Stick an equal sign between it, now it's a proportion. We already learned how to solve these things last semester. When they said that it varies directly, they're telling me that I can set up a proportion like this. Y varies directly with x. 35 is to 5. So what is y, so I'll just put a y there, when x is 9? Look familiar? Okay. Jesus fish. Okay. Alpha. Okay. For those of you who weren't in here last semester. Okay. Alpha, the small Greek letter alpha. Alpha and the omega, the beginning and the end. You see the Jesus fish. It literally is alpha with the word Jesus in it on the back of Karen's van driving downtown. Okay. It's alpha. We call it that because I can set up this multiply by the two things that line up, divide by the one that doesn't. Now, if you want to do cross products, you can. Okay, 35 times 9 is... Okay, so you'd have 315 is, and if I multiplied this way, 5y. Well, you're going to have to divide by that 5 anyway, right? So if I'm going to multiply these two to get 315 and then divide by 5, then just one-shot it instead. So you take the two that line up and divide by the one that doesn't. These two line up, divide by the one that doesn't. See? Alpha. Okay? It's just whether alpha is going to be on its side or whether the goldfish is like falling down in the tank. Okay? But it's multiply the two that line up, divide by the one that doesn't. You can one-shot that in your calculator. What's 315 divided by 5? Ta-da! So either I can find k and plug it into this form, or I can just set up a proportion, y over x equals y over x, shoop shoop, cross multiply and solve. You get your choice. And contrary to the kid who tried to meme at me, no, I don't care how you do it. You pick one of those. Which one works for you? Which one makes more sense? If you like the, I'll just divide them and now I know what to multiply by, do it. If you would rather set a proportion, do it. But either way, show what you're doing. Especially going through all those notebooks. There's an awful lot of assignments that have nothing but an answer. Show your work. You ain't getting credit if it's just a number, because I don't know if that's you who did it, if that's Slater, if that's photo math, if that's copying them out of the back of the book. I don't know. Have some work to back it up. Okay? Same thing goes. They say it varies directly. So, whether you want to set it up equation style or proportion style, figure it out. What's the other y? Y equals k times x. Plug in what you know, solve for what you don't. Okay. Hey, don't overthink them. Option A, option B. Option A, y equals k times x. They just told me y is 10 when x is negative 2. Divide. I got k is negative 5. So if I know that, now I can say y is negative 5 times x. They asked, when x is negative 15, what's happening? Okay. I start with the form of my equation, solve for the thing that's missing. Okay, now go and answer their question. Option 2 says, I don't want to do any of that. That sounds like too many steps. If they very directly think of them as being directly across from each other, y compares to y as x compares to x. Directly. So, if y is 10 when x is negative 2, what is y when x is negative 15? Multiply the two that line up, divide by the one that doesn't. Okay. I say 10 times negative 15 is negative 150. Negative 150 divided by negative 2. Also 75. You choose the method that works for you. Anyone got a preference?
Jesus.
I mean, we're in here last year, so you're probably just used to hearing Jesus fish. Okay. Anything else? Like, are both relatively simple? You got two different tools. Okay. You choose which one you are comfortable with. I really do not care. I just want to give you the tools. You make the decision. Okay. You ever had the parent speech, I just want you to make good choices? So, I'm betting that we're okay with that, but I want to know if you're okay with that when it starts getting funky. You know where I'm headed. Fractions and decimals. I want you to try 6 and 7. Same thing, it's direct variation. Set it up the same way, but now there's decimals and fractions. Let's see what you got. Show me you can do decimals and fractions. And don't just sit there and wait for me to write answers. There's a difference between you can do it versus you can write things down. Okay, big difference. Show me you can set it up. Even if the calculator is doing the work for you, you still set up, you still know what you're doing. Okay, if you're this far into the year and you still don't have your own scientific calculator with fraction mode on it, probably get on that. If it's something that you want but haven't been able to get for yourself, Just come talk to me on the sly, on the side, and I probably got a few laying around. Okay, I might be able to hook you up. But something that has that fraction mode on it is absolutely critical. You don't want to be doing things the hard way. Let the calculator do the heavy lifting for you. You're going to use it for the next 2.5 years at least. At a minimum, you have to take math through your junior year. I understand sometimes the resources are an issue. Okay, the one that Maddie's got back here, my calculator from 6th grade looked about like that. I ran with that all the way through my 2nd year of teaching. Calc 1, 2, 3, differential equations, ring theory, topology, non-Euclidean geometry. All of it. On those, alpha, y equals. Green button alpha.
Okay, so alpha
Y equals is top left corner. Gray, top left corner. That brings up a fraction menu. Just hit enter on n over d, and it gives you box over box. Okay. Most scientifics, there's just a fraction button where you just hit box over box.
Why is it
Okay.
set up on scientific notation? Like it gives you the 3-point times whatever 10 to the.
Okay. You got to know the tool that works for you, right? Let's see if we can find the mode to change it. Oh, that's right. Aren't you guys doing that in physical science right now? Who was that came in the other day? Right? You guys are all using that EE feature on your calculators? Okay. All right. Option A. Y equals k times x. So negative 4.8 is k times negative 1.6. Divide. K is 3. If k is 3, I can now say y is 3 times x. Oh, they wanted x instead. So I'll plug in y. Divide. X is negative 8. Option 2 says I'm going to set up my fraction over or equals fraction, called a proportion. And if I have y and x, y and x, then you, Jesus fish, multiply the two that line up, divide by the one that doesn't. You can even put a little smile in there and call it the snack that smiles back. Okay. Y'all probably don't even remember those commercials. Goldfish? They still do that jingle? Okay. So I could do that. No, you can one-shot that in your calculator, even on the dumbest calculator, even on a Lucky Charms watch calculator from 1992. You can still say negative 24 times negative 1.6 divided by negative 4.8. Okay? Multiply the two that line up, divide by the one that doesn't. Now the fractions. It's getting a little dicier. Either I can set it up, y equals k times x. So 1/4 is k times 1/8. Y'all remember? Besides just grabbing a calculator and saying divide by 1/8. Dividing by fractions. I heard it's easy, like pi. You flip the second and multiply. If you were in here before, you heard that so many times that you're just rolling your eyes. Please tell me you all have heard that rhyme has to have been in place since like 5th grade, right? Dividing by fractions is easy as pie. Flip the second and multiply. No? I got that burned into my head by Mrs. Itzen from Emerado, North Dakota in 1995. I can't get rid of it, but it works. It works. Multiply by 8 over 1, multiply by 8 over 1. Cancel, cancel. K is 2. Right? Because 8 times 1 is 8. 1 times 4 is 4. 8 divided by 4 is 2. Hit enter, and it'll just simplify it for you. That's the fun part. And if k equals 2, then go back and find when y is 3/16, k we just said was 2, go find x. Well, if I'm going to divide by 2, it's the same as multiplying by. Flip it. Please tell me. The reciprocal of 2. Come on. Okay. So if I multiply by the reciprocal of that, what am I multiplying by? Flip it. Reciprocal. 1/2. Cancel, 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 cancel. Cross canceling. Okay. So I get x is 3 times 1, 2 times 16. 3/32. Now, if I'm doing that as a proportion, it's going to look a little goofy. They're called compound fractions. A compound fraction is when you have a fraction inside of a fraction. Y over x is y over x. This is why I say get yourself a good calculator that you are familiar with. Now, I could multiply that on my own. I ain't scared. Multiply the two that line up, divide by the one that doesn't. So I'm going to have a 3/16 times a 1/8 times, because multiplying by or dividing by fractions easy as pie, 4 over 1. Right? I'm going to divide by 1/4, so I multiply by 4 over 1. And then, well, 4 cancels with 8, turns into 2 and 1. 3 times 1 times 1 is 3. 16 times 2 times 1 is 32. I can set it up like that, or fraction mode. Let the calculator do the work for you. 3/16 times 1/8 divided by 1/4. 3/16 times 1/8 divided by 1/4. Okay? If you got the calculator that's going to do it for you, great. If you got the fraction mojo because you remember middle school, great. I just want you to get to the answer and have some work to back it up. I'll tell you right now, direct variation stuff, expect that on a daily quiz or a test, you're probably going to have one that has a decimal or a fraction in it. Okay? It's the same process. You just can't be afraid of decimals and fractions. It's the reason we spent so long in it back in elementary, middle school. So, graphing it. Good thing we know how to graph by table. Weight on Mars varies directly with the weight on the Earth. The weights of science instrument on board Phoenix Mars lander on Earth and Mars are shown. So on Earth, they weigh the thing, it's this much. Shooting into space, go land on Mars, weighs this much. 50 pounds versus 130 pounds. Y'all been through enough stuff with basic science. You know what weight is? What? Mass times something. Okay, times whatever the gravitational constant is. Okay? The gravitational constant is the amount of pull that the planet will have on an object per how many grams or kilograms. Do you know that that varies based on how far you are away from the center of mass? That you will actually weigh less at the top of Mount Everest than you will in Spearfish, South Dakota. Weight is not how much of you is there. That's mass. Weight is gravity's pull on you, and the further you get away from the center of the Earth, the less it pulls. Okay, there's a famous experiment done a long time ago. I don't know if any of you remember the. Have you ever seen the Travelocity gnome? Travelocity commercials. There was this little gnome, and no, it's like they probably haven't aired those commercials for 5-6 years now. But they took this gnome. It was I want to say Caltech. They took this gnome very, very specifically, like measured it down to like the hundreds of thousands of micrograms, very specific instruments. They measured this gnome and then they took it on a plane around the world and they just measured its weight in different elevations all around the world. And they were able to conclusively show, like, yes, it actually weighs different based on that. So why would the weight be different on Mars? There's literally less Mars there than there is Earth. Or the composition of it is different. You've all talked about different moons and planets and stuff. Some of them are just a big honking chunk of metal. That's going to be very dense. It's going to have a lot of pull to it. Versus something like a gas moon that's just a bunch of clouds swirling around this tiny little nickel core. Well, it's not going to have very much gravity because there's not a lot of stuff there. So that's why it weighs differently. Go ahead and write that. If they say Mars is Y, I'm going to multiply it by something to find, or multiply Earth weight by something to get Mars weight. Well, go ahead and find K. Find that constant of variation. The Mars weight was 50. The Earth weight was 130. Get K by itself and divide. Okay. 50 divided by 130. Y'all remember the trick for reducing by 10? You just knock the zeros off of there. I hope. Otherwise, you can just dump it in a calculator, 50 over 130, hit enter, and it'll tell you 5 over 13. So, what is an equation that relates the weight? Now that I know this, I know my equation. Mars weight is 5/13 of Earth weight. Okay. Killian, you think you're tiny now. Wait until you get on Mars. You'd be like 40 pounds. Okay. What is the graph of the equation? Well, I've got an equation. I can start plugging numbers in. X, Y. Do you remember what our trick was for what numbers to pick for X when my equation looks like this? Had something to do with that fraction. I can literally pick any number I want. But if I want things to go smoothly for me, what if I didn't want to have fractions as answers? All right, no one's willing to talk. Start pressing buttons in a calculator. Put a 1 in, a 2 in, a 5 in. Start putting numbers in until you get a whole number. 5/13 times thing. 5/13 times thing. They're all going to be nasty decimals unless I pick specific numbers. Start guessing and checking until you run across a number that it comes out nice. Okay, if we don't remember our trick from last semester, was that last semester or is that the beginning of this one? No, time's irrelevant. Pick numbers, plug them in. 13 came out clean. It is not a coincidence that that has a denominator of 13. They're going to cancel. So if I want numbers that are going to come out nice, because it has a denominator of 13, pick multiples of 13. Can you count by 13s? What's next? We're usually good until that, and then we have to start going to the next place value and we goof up. Okay. All right, that's enough points to start seeing what's going on, right? Plug them in. If I shove a 13 in there, 5/13 times 13. Sailor said it was just 5. No, do not use the decimal, use the fraction. If you use the decimal, these will never come out nice because you're actually losing part of your answer. Okay. 5/13 times 26, what do you get? How about you, Dominic? Come on. There we go. Someone says words. What about 39? 15. We see the pattern, right? 20, 25. Okay? Because that's my ratio. For every 13 that this goes up, that goes up 5. That's literally the rate between them. If this moves 13, that moves 5. This moves 13, that moves 5, because it's 5/13. It's the slope. Slope is not just a number I come up with. It is literally the ratio between the two. All right there? Oh, okay. All right, how am I going to fit this data on here? I'm going to do that to ... until I get to weight on Mars was 50, input was 130. I've got 10 boxes in each direction. I need to go out to at least that to fit the rover. What do you want to go by on the x-axis to fit a minimum of 130?
You say we have 10 boxes here?
20.
Go by 20s, 15s. 15s and 20s would both work. Which do you want to do? Okay. If I did 10s, I'd have to go way off-road to fit that last one. It would work, but I'd have to go off-road. Okay. Let's not overcomplicate things. Keep it simple. I like the idea of going by 20s. Okay. Beat me to my punchline there. Okay. 40, 60, 80, 100, 120, 41, 60, 180, so on. What about my y-axis? I need to get up to at least 50. Got 10 boxes. Go by fives. 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. What is missing from this scale? Words. What do those numbers mean? X was what? Come back up here. Earth weight. And Y was Mars weight. And I'd go plot my points. Okay. Now they're going to have to be ballpark. About 13.5. About 26.10. About 39.15. About 52, like halfway here. 20. About 65, a quarter of the way there. 25. 130. 50. If we did it right, those should connect in a straight line. Please use straight edge. Student ID at a bare minimum. McDonald's gift card. Learner's permit. You got something. Now, who was that over here that said go by 13? Okay. If the ratio is 13 and 5, then just, you can always make your scale. Just do that. I could literally put those numbers on here and instead go 13, 26, 39, 52, 65, 78. Okay. Ah, there's something on my marker. All right. 90, I can't think right now. Man, I'm tired. And then 104, right? Or 114? 104. Okay. Okay. If I went by that, then my graph is just poke, 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 poke. Did I go one box too far somewhere?
Yeah.
Oh, this. All right, whatever. We could do. I went too many. Okay. The idea is you're going to go straight down the middle if you just keep those ratios. Okay. You make the scale whatever you need to. You just have to fit your graph on there. The next one, rate an equation. What is a graph of the equation? It's been a long time since we've had to freehand graphs. I normally have the graphs there for you. Can you do it again? Can you make a table or a slope? Okay, we know what slope is now. Can I use that ratio of going up this many and over that many? And can you sketch a reasonable graph that isn't just completely BS'd? It actually has a scale to it, a proportional scale. Had a couple of class mons last semester in Algebra 2. Hyper-organized kids. They would take and cut a piece of graph paper out and then just tape or glue that onto their assignment for their daily quizzes or their assignment problems that needed graphs. It works. If you don't have a graph paper notebook, that works. You can do that. The one girl, she overkilled it. She had graph paper sticky notes. Like pre-printed graph paper sticky notes. Or you could be the artist in the room and have a full-on graph. Okay, y equals k times x. You know y, you know x, go find k. Now that you know k, start plugging stuff in. This is trash. I'll make that a little better. Ain't gonna do itself. Moon versus Earth, y versus x. They say 100 pounds on Earth. Is that y or x? Okay, plug in 100. They weigh 16.6 pounds on the moon. And think about that. Okay, 100 pounds. You're only 16 on the moon. Divide. Y'all are doing scientific notation right now in science. What do I do to the decimal when I divide by 100? I know it's two places. Is it two places right or left? Okay. Well, if I'm taking something that's 16 pounds and dividing it in 100 pieces, should they be smaller or bigger? Okay, way smaller. Move the decimal two places that way, 0.166. So if I know that k is 0.166, man, how am I going to write that? Y'all got a calculator next to you. Do you know where your fraction to decimal button is? Look around on your calculator. you should have a button that says FD or SD, or Killian's, you just got a straight up convert button right above enter. Okay, everyone should have a button like that on their scientific.
How about this one?
Okay, on those, that's the same emulator I got up here, you're going to go through a math menu. So if I have 0.166 and I want to turn that into a fraction, math, change it to a fraction. 83/500ths, which we should be able to just take 166 over 1,000, right? 166 thousandths, it's in the thousands place value, and turn that into a fraction, or reduce it down. So if this is also 83/500ths x, if I wanted to make a reasonable graph for that, maybe this is 83, 166, and so on. Could do it that way. Maybe I just BS the whole works and say, you know what, that's about 100 over 500. My bottom axis, my x-axis, I'm just going to go by hundreds. 100, 200, 300, 400, 500, 600, 700, 800, 900, 1000, 1000. And go by 500s. 500, 1000, 1500, 2 grand, 2500. What if I didn't want to do any of that and I wanted to label it a certain way? Could I instead say 5, 10, 15, 20, 25, 30, 35, 40, 45, 50? But on the side, I will say X was earth weight. So have that backwards. Yeah. Weight, but I'll put in hundreds times hundreds of pounds. Okay, hi.
I thought Earth weight was the X and Y.
Yeah, this is 5. Oh, yeah, it was. I did it backwards. Good call. You got me. I even said backwards, but then I just went with it. Yeah. Earth weight. Earth weight pounds versus Mars weight. Or what is this? Moon weight. What axis did all of you choose? I'm going to get an actual graph up here. Okay. Okay, so I had my numbers completely flopped there. Or did anyone even make their graph? Jesus, freshman. For the handful of you that are actually doing this, shortcut. If I have 83 over 500, we said that that slope is rise, which is y's, over run, x's. You can just make the graph whatever you feel like. And say you go 500, 1,000, 2,000, 3,000, 4,000. I can make it whatever I feel like by just Jesus fishing this thing, setting up as a proportion. If I have 83 over 500, maybe a dot, set yourself all the way out to 4,000. Or whatever your scale goes to. Cross multiply and you'll get the y coordinate with that. So I'll have a ratio of 500 to 83 versus a ratio of, what's that, by 864, 24? No, 640 with 24, 664. There you go. You can do that for one extra point. So all you need is your first point and whatever your other point is, just connect two dots instead of doing 15 of them. Okay? So it's a shortcut for those of you that actually did the graph. For those of you who didn't, oh well. Can't come soon enough. Writing it from the table, all you got to do is identify your variation. First thing, is it direct variation or not? Am I taking 10 times k, 8 times k, 4 times k, and it's the same every time? Now, if you know fractions, you're probably good with it. You say, yeah, I don't know what the number is, but yeah. Maybe some of us are starting to lean towards it's times 1.5. Okay? To determine if something is actually multiplying by the same k factor, so it's actually a direct proportion. Remember, y equals k times x. That means k is y divided by x. That was on our very first page. So for every one of these, do y divided by x. And make sure they're all the same. Take 15 divided by 10. I get 3 halves. Take 12 divided by 8. Reduce it down. I get 3 halves. Take 6 divided by 4. Reduce it down. I get 3 halves. Because every one of them had a y over an x, a y over an x, a y over an x, and they all equaled the same thing, then y over x equals the same thing. Okay, it's a direct variation. They're all doing the same thing. They're all multiplying by 3 halves. So what's my equation? 3 halves x. But I'm not going to find that without dividing. I'll tell you right now, some of these book problems, they're sneaky, where they're going to make 2 or 3 of them would be 3 halves, and then one of them would be 4/3. It'll be just a little bit off, just to mess with you, to show you it's not actually direct variation, there's something else going on. And since this one worked, I bet that's how the second one is going down. Each one of them, take 1.6 divided by 4. What you got?
0.4.
Take 2.4 divided by 1. Well, that ain't the same. Take 3.2 divided by -2. Okay. Not only were all 3 of them not the same, but none of them were the same. That is not direct variation. So I don't even write the equation, and just say not direct variation. And I'm done. I can only write the equation in that form if it's that type. I can only tighten a screw with a Phillips screwdriver if it happens to be Phillips. Well, I suppose if it's like a T6 or a T10, you could probably just jam it in there hard enough and it might work, but don't do that. You ruin it. You know, that's why they put really dumb screw heads on all of the, like, anything in a public boys' locker room or bathroom. It's because guys are dumb. They do dumb things to the bathroom. You've all been in that one. Okay? So, same thing. Is it direct variation? If it is, now you know what K is, write the equation. But you have to find K and make sure it's the same with all three of them to confirm that it's actually direct variation. Finding that constant of variation, it's what allows me to start extrapolating, to start making formulas. Start predicting things. Say things like, this particular antenna array on the Mars lander is exactly 612 grams. Will it handle the stress of landing? Because it has to meet a certain ratio. I've got direct variation for that. Okay, each time. Y divided by x, y divided by x, y divided by x, do they all come out the same? In this case, all of them are going to be either negative 0.75 or negative 3/4. They're the same thing. One's a fraction, one's a decimal. You take your pick. I'm okay with the decimal this time because it's terminating. I don't round it off. So I'm okay saying that. So you're either going to tell me y is negative 0.75x, or you can say y is negative 3/4 x. I'll take either one of those as the answer. And if you need to make that note to yourself again for about the 300th time over the course of the year, it's okay to write this decimal because it's terminating. It stops. I'm not losing part of my answer. You ever see someone have the old 0.9 or 9/10 at the end of the prices by a gas station? They'll say it's like 3.24 and 9/10, or $3.24.9 per gallon. Okay, that round off there. They do that so they can say that it's under a certain price. You ever seen an ad pop up on your phone? Heard it on the radio, seen it on TV, where they say, for only $49.99. They say that so they can say, this is under $50. And you're like, no, it's just $50, dude. You're just messing with me. Then you're going to throw tax in there. And now it's actually like 51.14 or something. Okay? It's okay to call this 0.75 because it's just done. If it was that 9/10, if it was that 9/17, if it was that 38/57, then you're going to have to change it. You have to make sure it's in fraction mode. So, Either we can or we can't. I don't know. I'm kind of torn here. Part of me says we should do the practice. The other part of me says it's only the 4 that are following along with that are even going to do it. The rest are just going to copy it maybe later. Can we do this? Because I guarantee you're going to have 1 or 2 word problems with your assignment. Or do we maybe want to see it just to double check? Or just give me the assignment, I'll photo math it. Okay? Kind of torn on that. Really torn on that. So, since everyone's just staring blankly, it's like looking at a jar full of grasshoppers. I guess we'll just finish off there. We'll give you your